let's do this 12.1 self-quiz. So find the values of the 6 trigonometric functions for angle theta. So there's my theta. First thing I notice, I don't have the hypotenuse, so let's find it. Remember the way we find that? Here's my hypotenuse. It's opposite the right angle. You can do a squared plus b squared equals c squared. Hypotenuse is always c. So I have a and b, doesn't matter which one's which. So I get 8 squared plus 6 squared equals c squared. So I get 64 plus 36 equals c squared. 100 equals c squared. So c equals 10. So there's 10. Now I can fill out this stuff. Remember the key to this is this SOHCAHTOA. So for sine, that is so. We're going to do opposite of adjacent. So I want to label the sides. That's my angle. So this is opposite. This is hypotenuse. And that makes this adjacent. So sine's going to be 8 over 10. Cosine, SOHCAHTOA. So adjacent over hypotenuse, 6 over 10. Tan, TOA, opposite of adjacent, so 8 over 6. And then I gotta find the reciprocal functions. Now the key here is to understand which one goes with which. So sine goes with cosecant, which makes this the reciprocal, 10 over 8. Cosine goes with secant, so that makes this the reciprocal, which is 10 over 6. And tan goes with cotan, so that makes it 6 over 8. There we go. Again, I don't really care about reducing. So next ones. Use trig functions to find the nearest x, round to the nearest tenth if necessary. So here's my angle. So we want to label the sides. This is opposite. This is hypotenuse. So the only thing I have here is O and H. So that is so. Helps if you spell it correctly. So sine of the angle 24 equals opposite over hypotenuse, so 11 over x. This is a more annoying one, so we gotta multiply by x to solve for x. So I get x sine 24 equals 11 divided by sine of 24. So x equals 11 over sine of 24. And again, I'm fine if you want to leave it like that. That's okay. If you want to put in your calculator also, that's also good. So that'll be, gotta make sure we're in degrees, so we're doing that. So default's generally radians. So I'm going to do 11 over sine of 24. And we get 27.0. 27. It's the nearest tenth, so 27. So there we go. Same question here, but now I believe our x is the angle. So we'll do the exact, and then here's our x. This is opposite, which we don't have. Here's adjacent. This is hypotenuse. So we have A and H, that's ka. So cosine. So cosine of x equals opposite of adjacent over hypotenuse, so 15 over 17. Kind of hard to read with my writing. Now remember, if you want to get rid of cosine, the way we can do it is cosine inverse. So take the cosine inverse of both sides. Those two cancel each other out. I get x equals cosine inverse 15 over 17. I'm going to put that as a calculator, so it's easier. 15 divided by 17. And I get 28.1 degrees. So there we go. Application problem. A scientist at NASA's Jet Propulsion Laboratory is attaching a weather balloon to the ground to help measure the atmospheric pressure. The balloon is attached to the ground with 100 meters of rope. Using a bubble protractor, the scientists found that the angle of elevation from the ground is 85.2 degrees. Find the height of the weather balloon from the ground. So a lot of things going on here. Here's my ground. I have a weather balloon at an angle of elevation of 85.2. So something like 85.2. Here's my weather balloon. And we have like a height. So key things in figuring out where to put everything. So we have our angle. The question is, find the height. Height's always next to the right angle, so this is my height. What's 100 meters of rope? Well, think about it. It's tied to the ground. This is the rope. So this is 100. I've seen a lot of people put this as the rope right here. Like, no, that's the height. Height always has the right angle. This is the rope, and that's the ground. So given that, let's label the sides. Here's my angle. This is the opposite. This is the hypotenuse. This is adjacent. So I have O and H, so that is sine of 85.2 equals H over 100. Now, since this is an application problem, I do want an actual answer. So I'm going to go to my calculator. I'm going to multiply both sides by 100, I guess, first. And I get H equals sine of 85.2 times 100. So 99.6 meters high. So there we go.